Alright, hey guys, got a pretty interesting thing to take a look at today. This is a very old, very early thermal imaging system. This was built by Inframetrics. This is the model 445L, serial number 31. Here on the back side we have simply connection. We have an hour meter on it, which reads over 600 hours, if that's accurate. We also have here a humidity indicator and a breather vent, and then the hardware to fasten the cover to the case. On the front side we have not much to see because we have a lens cap. And behind this lens cap, we have quite an impressive lens. So I'll remove this cover so we can take a look at it. Here we go. Look at that. That is quite an impressive lens, and that measures almost 9 inches in diameter. You can see my reflection in it. Anyway, we have, appears to be a surface coating on it that has broke down over time, possibly, presumably from exposure to the elements, as this is a system that would be installed outside, either on a mast or on a observation post. This did come with a sun shield, which sat on it like that, just to keep the intensity of the sunlight off of the body, keep the internal temperatures down. And I have also a cable for it, which looks like a 30 or 32 pin connector, and that cable is maybe 100 feet long, so at least I can put it far away when we test it. And it also came with a power supply, and this is a 55 watt output, 12 volts, 4.6 amps, and 4-pin Amphenol connector that I can't plug in anywhere, so I don't know how good this is. I think we'll just throw this in the bin. The body of this is about 24 inches long, and it seems like this portion is mostly optics, and back here we'll have control circuitry and image detection. I'll pull this cover off and we'll take a look inside this cover. In here it looks like we got a electromechanical assembly to swing a lens element into or out of the optical path, presumably to change the zoom level. And that just simply turns 90 degrees one way or the other. And it has a small feedback potentiometer here and a geared servo motor. So that will just switch back and forth depending on the zoom level that the operator needs. According to this small article I found online from the Spanish Navy, actually, they acquired a few of these cameras, and it states on here that the performance of the system is capable of detecting ships up to 38 kilometers, aircraft up to 17 kilometers, vehicles up to 11 kilometers, and people up to 6 kilometers. So we have quite impressive zoom on this camera system. Alright, so that's it for the top. So I'll go ahead now, we'll remove the cover for the electronics assembly, and we'll see the control electronics, and we'll also see the imaging system. Okay, look at that. Inside the case, there isn't a whole lot to see. We have the milled interior here, and we have the air vent and the desiccant pack, which suggests that perhaps some components in here may be moisture sensitive. Okay, so here's all the control electronics. It appears the imaging system is right there on top. Back here it looks like we have the main infrared detector back here. We have its front end circuitry. On top it looks like we have the control electronics for the image scanning system, as presumably this uses a galvanometer based image scanning system. Over here it looks like we got power supply boards, and over here perhaps digital control boards, maybe for the video processing. And on the bottom we have the back plane. So I'll go ahead and we'll remove these boards individually and we can take a look at them in detail. All right, here's our first board from that camera. This looks like all power supply. It looks like down here we start with input filtering. We have 3 large caps coming around. This section looks like a DC-DC converter. We have a single inductor here, N-channel MOSFET, a TO3 package. Over here we have a power Schottky rectifier. Coming up we have classic UC2524 switching controller. Next to that we got a dual high-speed MOSFET driver. Next to that we have just a simple op-amp, trimmer up there, and it looks like a coax that snakes from the bottom up to the top, and that ends up inside this op-amp somewhere, so that's probably controlling a voltage level. Continuing this way, we got a 5-volt regulator, pretty simple stuff. And below that we have a minus 15-volt regulator, LM302T or LM320T. And then this package here is actually also a minus 15-volt regulator. It's actually in a TO39 package. Why they would have two minus 15-volt regulators in 2 separate packages, I don't really understand that. This is our transformer. And next to that we have a couple of full bridge. Looks like we have some dial arrangements for rectifiers and then smoothing capacitors. Up here we have another inductor core. Next to that we have another N-channel MOSFET. Down below that, it looks like we got another gate driver. Going around, we have another classic UC2524 switching controller, and another smoothing capacitor for its associated power rails. Then we got just a simple flip-flop down here, and another dual MOSFET driver. And this dual MOSFET driver apparently is driving these 2 IRF 130 power MOSFETs. And a curious thing about this board is that we have 3 of these dual output gate drivers, but each one of them is different in that this guy here is a inverting driver. This guy over here is a non-inverting driver, and then this driver here is a complementary driver. So we got all three flavors of dual output drivers on this board. On the back there isn't anything else to see other than a small bodge capacitor on there. And also probably the fattest tantalum capacitors I've ever seen on a circuit board. I mean, look at the size of these guys here. Massive. Little note, we have a small, I think I measured this as a 5 microhenry inductor, and that looks like it was, the PCB trace was cut and then that was added in afterwards. Alright, that's our first board. The second board here is also pretty simple. Presumably based on the devices on the board, I would say that this is probably controlling those DC motors that are used for focus control and the zoom selection. Just going around, basically we have just JFET op amps over here. This guy here is actually a operational transconductance amplifier, and the way that works is that it outputs a current source based on its differential input. Up here we've just got another dual JFET op amp. Don't see what this part is. Oh, this guy's just an LM741. All right, 2 test points here, not marked. This is a pretty interesting component here. I measured this as a 5 Henry inductor, and interesting, it has a note in here that says it has a max altitude of 75,000 feet and a max operational frequency of 400 hertz. Continuing around, we got a just a regular general op amp here. This device, just a CMOS analog switch with 2 independent single pole dual throw switches. Another JFET op amp here, and then another CMOS analog switch. This one is different in that it has 4 independent single pole single throw switches. At the bottom here, we got a 2N6107. It's a PNP. Then this guy up here, 2N6292. That's our NPN transistor. And then we have the same over here, same arrangement over here. This guy here is our LM101 op amp, and that's pretty much that for that board. In the back, nothing to see here. And there's also a small 6-pin device here, which appears to be a I think that's a dual transistor package here. And right in the middle here we have a LM236, and that's a 2.49 volt voltage reference. All right, here's our third board. Appears to be split. Appears to be 2 main sections here. Off the bat here, we got this is 22CV10A. This is a programmable electronically erasable logic device. PEEL. PEEL. Programmable electronically erasable logic device. Next to that, it's just a M74HC 86A. It's a OR gate. Over here in this section we have a bank of MOSFETs and transistors. The row on top and bottom are both SD2100 N-channel depletion mode MOSFETs here. In the center we have a bank of these are actually super beta monolithic dual NPN transistors. The part number is LS301. Small trimmer capacitor down here. Another small dual NPN transistor package here. This guy here is another one of those CMOS analog switch. A small device here, which is a 1.2 volt reference diode. Just noticing some soldering iron damage on this transistor case here. These two devices, which are linked together by it looks like a solder braid on top. These are LM194 matched NPN transistor pairs in each package. This side is pretty much symmetrical to the other side. On the top here, we just got a couple of just JFET op amps and a set of trimmers. And then this pin header actually connects up to that kind of strange looking vacuum package optical electrical device. Back, just handwritten serial number 31. And on the back side of this board, not a whole lot to see here, just quite a few baud resistors here. There's one down here. You can kind of see that's coax snaking under the board here. And those are going right up to our transistor pairs. So we will look more closely at that imaging tube. Baud resistors on that side. So more micro coax on the board here. Another small trimmer. We have quite a lot of corrosion around these pins. So getting this thing to work is going to be a little bit questionable. Some details of the modifications here. I'm gonna go ahead and guess that this may have something to do with image scanning. Perhaps one side has to do with the horizontal axis, and then the other side may have to control the vertical axis. Here's the next board out of that unit, labeled as the 8-bit video processor. So over here on this end, we have two. These are CMOS 8-bit high-speed analog to digital converters. Those are apparently taking the signal from the image detector and converting them to digital signals. Again, above those two we have these guys, which are two LT1010 power buffers. Apparently taking the signals out from these two chips and amplifying them. Right over here we have another dual JFET op amp. These four components here are high input impedance, wideband, uncompensated operational amplifiers. Those three of them, those are, that's the reference number there on those, 2625. This is another one of those CMOS switches. These two devices are basically similar to these, except that these are just slightly lower spec'd out. These are the HA2 2605 op amps, and over here it's got a single JFET op amp. Yeah, that's basically it with this board. On the back there's not a whole lot to see. No bodge wires, no modifications. Alright, here's the next board. On the back, on the front. Alright, starting on this side, we have our, this is a TLM 1840. This is an 8-bit video digital to analog converter. Small trimmer next to that here. Nothing else really exciting up here, just some simple logic. Up here, this guy, binary counter there. This is our, this is a 16 kilobit EEPROM. Just under this label we can see the die of that package in there, and I'm assuming that this is storing some, maybe this is storing some patterns, or perhaps this is storing some patterns to be displayed on the video output. Maybe it shows a set of crosshairs, or it indicates the zoom level. Coming around here, nothing else really to see. 74HC6N, this is the flip-flop. And this nice package down here by Ferranti, this is actually a TV synchronizing pulse generator. So that'll give us our synchronizing signals for our TV output. Apparently this board here is outputting our composite video signal, which we can look for later when we get this thing powered up. We can try to look for that video signal. Alright, here's board number 6. Not a whole lot happening here on the front or the back. Just two bodge wires here and here. Okay. Just on here we have two static RAMs, and then just various 74 series logic around here. These two guys here are 8-channel buffers. These two guys here are just a couple of analog multiplexers. And this is our, in the last board here, mostly populated with just some logic chips. Down here in the corner, low offset voltage op amp. Up here we just have a another standard op amp surrounded with its little group of components here. Coming around the top, not much else to see here. Little ceramic package. It's just a 6-channel inverter. And another set of interesting chips down here. This is a 8-bit magnitude comparator, and then just a standard PROM over here. And this chip here is a precision 5-volt reference. And not much to see at the bottom. Small resistor here. And interesting thing I noticed on this board is that we don't have the typical decoupling capacitors mounted adjacent to these chips. From what I can see under these chips, it looks like we have some type of flat, maybe some type of flat form factor capacitor mounted underneath these chips. 4 leads, 2 on each end. And those look like they connect onto the power rails. And there's one underneath each logic chip here. You can just barely see them underneath there. Got a little bit better view up here of those. Don't know what you would call these. Some kind of flat form factor capacitor. Pretty interesting. I've gone ahead and I removed the backplane card cage assembly. Inside there we can see the backplane. It's labeled as Loris backplane. Loris being the series of thermal imaging cameras that this company came out with at the time. We have 2 trimmers up here, NF and WF, which let's guess that means near field and wide field. And a couple little chips down there, maybe just setting some analog values. Nothing in the back side. Okay. So now we can get a better view of the actual detector assembly. I'll just go ahead and spin this around so we can take a look at it. Very interesting. Clearly some type of optical voodoo magic happening in here. Here's a better shot of the actual detector with its apparently some type of front end chip. When was the last time you saw a Sanchez integrated circuit, brushless? Can you look up that part number and see if you can find some information on that guy? Probably not, but I'll be surprised. Here's another view of that small device. Go. I don't know. Now it's not clear to me how this device is, what the actual form factor of this device is, whether it shares some type of vacuum with the detector, or maybe this is some type of prism in here, and this is some type of image intensifier. Not exactly clear to me. Not very familiar with this. Not super obvious what's going on here. There is a gap between this prism assembly, or this mirror assembly, and the face of the tube here. And we could see these little micro coaxes terminate at the feed throughs on the tube. This assembly here, this optical assembly here, has this PC board attached to it, labeled as a Loris scanner, and this has at least there's 2 up here, 4, 10. Looks like there's 10 pins that go from this board down into this block, and we can see them back there. I'm assuming this is some type of, this is the scanning assembly. This device has 8 wires coming out of it that ends up in this hybrid circuit. Looks like a hybrid circuit. And only other thing there is just 2 decoupling capacitors on the back side of this board. And the only output from this device is this wire here, this single wire, and it comes up to terminate to this connector here. Down inside the unit, there's not much to see. There's a set of lens elements in there. Down in there, we see the back side of the front element and the reflection of the moving section here, which you can see moving when I move it. And that would change between two zoom levels. And on this moving lens assembly, we have the small focus motor down there. And then we have another focus motor on this side. Okay, so I went ahead and I removed the fasteners that were holding this block assembly to the main optic assembly. And we're going to take a look inside and see what we find. Can't pull it off all the way because it's still attached by this wire here. So I'm going to get it clip this like that. And hopefully this doesn't disturb anything. It is loose and we can lift it off. And I'll just carefully just move it over here. And of course we can't see anything because it's a germanium lens and it doesn't pass anything visible. I'm just holding this here very carefully so we can look at it. There's the primary optic to the scanning assembly. There's its output. There's the input to that strange package device. And down inside, there's nothing else to see other than the back side of the lens element in there. That's just a hollow tube all the way to the front. If anyone has any idea of how this might work, or any documents or patent numbers we can take a look at, I'm interested in learning more about this and just seeing if I can get it to work so that we can perform some experiments on it. I hope this video was pretty interesting. It's pretty cool to see inside this thing for the first time. I don't think anyone has taken apart one of these on YouTube. If I manage to get it working, I'll certainly post a video on it.